Hi friends, today I'll give a presentation on the Uboot Beton Technology. Let us understand what it is. We will discuss about the introduction, parts of U-Beton, types of it, installation process, the applications, advantages of U-Beton, carrying capacity, its benefits of the system and the practice in today's world. So coming to the introduction part, what is U-Beton technology? So let us understand what it is actually. So it is the recycled propylene plastic polymer foam technology used for the construction purposes. It creates lighter economical design for the structure. So as you can see over here, these are box like structures and they are made out of recycled polypropylene, means the plastic polymer, and you can see here how they are. So this is used to construct two-way slab, large span slab, mushroom slab and raft foundation in the RCC structures. It is suitable for high-rise buildings, hospitals and parking management, residential and industrial buildings. Now materials for U-Boot technology. Materials used are cement, steel, fine aggregate, coarse aggregate, water and recycled plastic mold. The U-Boot shells. Now let us see the types of U-Beton. Generally there are two types of U-Beton. One is the single and other is the double. So first let us look at the single U-Beton. Single U-Beton means it has only upper U-Beton with foot and spacer. As you can see in this figure, this is the single U-Beton, okay, and this is the spacer here and this is the foot over here, and the size of it is usually in a square or a cube form and it is 52 centimeter by 52 centimeter, okay, the available height and the base, okay. So S means here the spacer height, as you can see here, okay. Next is our next type, that is double U-Beton. Double U-Beton, as you can see in this figure, it has both the upper part as well as the lower part with a spacer and a foot. So this is also available in various sizes of up boot, down U-Boot and foot height, where P is the foot height and H is equal to total height of upper U-Boot and lower U-Boot. So this H is total height of the upper U-Boot and the lower U-Boot, and the working dimension of this is also same as the single U-Boot, that is 52 centimeter by 52 centimeter. Next are the parts of U-Beton. So let us look what parts are mainly used here. There are three main parts of U-Beton. This, as you can see in this figure, it is called the spacer joint. So these are U-Boot betons and they are connected through this, means they are connected through the spacer joints, okay. So it is used to fix the position of U-Boot during construction. Main purpose is to fix the position so that they do not misplace from the position. Next, to maintain the rigid interconnection that ensure perfect geometry compliance with design as well as bearing capacity of the formwork. Next part is the connection bridge. So as you can see, this is the connection bridge and our two U-Betons are connected with this connection bridge. The third type is the closure plate. This is the closure plate and this is our single U-Beton. So when we fill it with concrete in the slab, the closure plate is used for not having the concrete fall off. Then let us look at the installation process. The installation process for the U-Boot is as stepwise. So in step 1, what we do is place the lower reinforcement above the formwork. So here the lower reinforcement, as you can see in this, is placed above the formwork. So here it is the formwork here, and above this is the lower reinforcement. Okay, and then step 2 is now place the U-boot. These U-boots are placed above the lower reinforcement at specified intervals, means at specified gaps they are placed with horizontal linkers. So connectors are used to link them. Then the next step is to now complete the upper reinforcement which above the U-beton. So upper also you will place the reinforcement like below you have placed the reinforcement. Okay, and then step 4 is now pouring of concrete is being done. So here as you can see, the concrete is poured in between these intervals, and it fills up all the gap left over there. And then step 5 is now concrete is totally poured and the slab is ready. Okay, now after setting of the concrete we will unprop the formwork. So we will remove the formwork, and it looks like this. Before pouring in concrete, the slab looks like this. This is the finished slab on the right side, and this is before finishing or before pouring of the concrete. Okay, upper reinforcement, lower reinforcement is kept. In between those, these U-betons are kept. Now next will be, let's look at the applications. So where all this type of technology is used? It is used to create large concrete span which having great bearing capacity. It increases the spacing of columns, which gives major benefits. It is used in high-rise buildings, commercial building, hospitals, parking lots, etc. As you can see, this is hospital. Suppose this is floor 1 and floor 2. So in between the slab, this is the slab of the hospital, and see here U-betons, double U-betons are used. So it saves the concrete, it is economical. And similarly here it's a parking lot which consists of 2 floors, and look at the slabs over here, all consist of the Uboot Beton Technology. And this is also again the hotel. Okay, and here also the slab consists of this particular U-boot technology. Next, in raft foundation. So it is also applicable in raft foundation. As you can see in this figure, these are U-boot betons kept in the raft foundation. So this one is the other diagram showing the same. To increase the bearing capacity where soils have low bearing capacity, it is used. It can make heavy construction above this foundation. So any type of heavy construction can be constructed above this. Then concrete saving as compared to making general raft foundation. So concrete is majorly saved in this type. Then provide great bearing capacity with lower thickness of this slab. So great bearing capacity is also provided. Then next, coming to the advantages, we have economical advantage first, and the economical advantage says reduction in cost of slab and reduction in the concrete consumption, reduction of steel consumption. So here this is the normal traditional slab or without U-beton, and here it is with U-beton. So if you can see here, it is thicker and this one is slightly not that thicker. So you can see the difference for yourself. It saves up lot of the material, so hence it is economical. And next advantage is our technical advantage. Under that comes fire resistant, reduces effective mass of the slab, reduces number of columns, number of beams between pillars, possibility to remove beams between the columns. Then extreme earthquake resistant, control vibration. So those were our technical advantages. Now coming to the architectural advantage, it provides larger space, then freedom of architectural design. So here it is shear resistant, this one is fire resistance, and then this is the earthquake or the seismic resistance. So it controls vibration. Normal building you can see it cracks and wears apart, but with this it is seismic resistant, it does not break. And then this is the base isolation. If we use U-beton in the base also, it will be more good for us. Then next advantage is our sound resistance. So due to this bubble deck slab, the concrete quantity is less compared to normal solid slab and providing the recycled plastic shells, so the sound resistance is more. So we use the recycled plastic shells and here sound resistance is more. Then carrying capacity. The tests have been shown that for a bubble deck slab, this is called as a bubble deck slab, with same load bearing capacity be used only 50% of concrete required for a solid slab, or with the same thickness of a bubble deck slab, the load carrying capacity can be increased up to 2 times by using 65% of the concrete. So it is helpful in the carrying capacity also. Next, let us look at the benefits of this. So, design freedom, downstand beams and bearing walls eliminated, reducing overall cost, reduced dead weights, longer spans between columns, construction is less weather dependent, reduced foundation sizes, reduced concrete usage, environmentally green, and also it is sustainable as reused plastic polymers are used. Then in today's world where all it is practiced, so in Bergamo, that is in Italy, ITC lab and research center, it is made up of this technology only. Then in Ireland, NAS shopping center, so here also this technology is used. And then in France, Sclay Nanotechnologies Research and Development Center, all these labs are constructed with this technology itself. Now ending this PPT, we can say that we can save more concrete and steel by that structure is more economical for us. So here less use of iron in the slabs, pillars and foundation up to a total of 15%. There are anti-seismic advantages connected to reduced building weight, slimmer pillars and foundations. There are low chance of seismic effect on the buildings. Due to the fact that the structural behavior of this new kind of monolithic flat slab is the same as for solid slab. Excluding slab edge column connection, we surely can talk about the appropriateness of use and advantages of the new technology. So this technology is very prospective in modern construction, and perhaps future of civil engineering belongs to this kind of hollow slab. So I hope you all understood about this Uboot Beton technology, and thank you for watching my video. Please do subscribe my channel. Thank you for today.